Yeah, yeah, okay. All right, hello everyone. Welcome to the Codebusters live stream. I'm Taylor Chitton.
And I'm V Lee.
All right, so we're just gonna go quickly over the rules and the ciphers for this event.
So again, it's simply just 50 minutes, one test. You get 3 people to do this, and you are allowed a calculator, though it can only be a 4 function. So that means it can only add, subtract, multiply, divide. I think also if it has a square root, you're allowed to have that as well. So a scientific calculator that can do like sine, tan, cosine, those kinds of functions, that's not allowed. Neither is a graphing calculator for the same reasons. Um, So the only kind of calculator you're supposed to be using is a 4 or 5 function calculator. Um, Most of these there's a set list of codes that we'll be going over. They're divided into 2 categories. One set is for regionals. The other is for regionals, states, and nationals. We'll start with the regional and invitational codes first. But the first question of any Codebusters test should be a timed question, unless stated otherwise. The first question basically will give you a lot of points as long as you're able to do it very quickly. It's the same kind of code, which is an aristocrat. Um, some of the other things you should keep in mind is that in most codes, you're allowed to make 2 mistakes on some of the letters before getting 100-point reductions. So if you're doing an aristocrat and you maybe mess up a couple letters in maybe like the word the, and maybe instead of putting the letter E, you accidentally put the letter Y, that'll count as one mistake for having the wrong letter from the answer key. But that won't mean you get the entire code wrong just yet. You're allowed to get full credit if you make just 2 mistakes on a code like an aristocrat or a patristocrat. But after 2 mistakes, every single mistake that you make will subtract 100 points from the maximum number of points that you can get from having the code correct. So if you have a code that is maybe worth 600 points, but you make 2 mistakes, you'll still get 600 points. But if you have 3 mistakes, then you'll get only 500 points, and then it keeps going down until you can get 0 points from it. You won't lose points for having too many mistakes, so try to solve one as fast as you can. But if you can't solve it before the time runs out, that's totally cool. You don't lose any points for having tried.
All right, so the first type of cipher we're gonna go over is an aristocrat, and these are probably like the most common cipher you'll run into, and it's basically a translation of one letter of an alphabet to another. So in the code, um, it would be A to a different letter, such as like Z or randomly. It was kind of random. There were 2 types of aristocrats. There were the K1 and K2, and these are differences in the ciphertext and plaintext. So in the K1, there will be a keyword in the ciphertext. So what you're translating the plaintext from, um, and you'll often be asked to um, say what this keyword is and identify it in your frequency table. Um, and then the K2 alphabet is just there's a keyword that's in the plain text, and it goes from alphabetical order with letters and the keyword missing between others. Uh, and as V mentioned before, there is a timed question for your first question. So typically there'll be a medium level aristocrat, and you will get a time bonus based on how fast you complete your question. and it is often the first tiebreaker when they're grading your test. So it is often like really crucial that you do well on this first time question. Some hints for aristocrats are just know like the common double letters, bigrams, trigrams, letters, the most common one letters, two letters, and so forth. There's kind of a list here that you can just screenshot or look at. I won't go through all of them, but um, aristocrats are definitely about identifying some easy to see patterns. Like if you see a three-word thing, you could just try like the and the or the or whatever, and try to figure out that. I also recommend using the frequency table, so you could just look at the most common like letters like E, T, A, O, I, N, and they will most typically be your high frequency letters in your table. And so, um, an easy practice site is the site cryptograms.puzzlebear. It just generates random quotes for you to put in, and you can test it. It's a little bit different from how the online platform is going to work because this website fills in for every single letter. So if you typed an A into the V slot, as you can see, like right here, it will fill in the A for all of them. But on the test, you won't be able to do that. It'll only fill it out for one of that single space.
So Patristocrats are almost the same as a regular aristocrat. The only difference is that you can't see the spaces between each of the words. So if I have a sentence like the cat jumped over the moon, you won't be able to see the spaces between the words the cat jumped, etc. So this does make it a little bit more difficult because now you don't know when a word starts and when a word ends, and you can't figure out how long a certain word is. You have to rely a lot more on the frequencies of each of the letters. You can apply most of the strategies that you get with an aristocrat. The only thing is, you just can't figure out you can't figure out certain words as easily. But again, looking for double letters will still usually be effective, even if it's the same letter for the ending of one word, but then the start for another. You can still usually use double letters to your advantage. You can still use the bigrams, the trigrams. The common letters will still work. Uh, Still look for common sets of letters like the appearing within the code. Um, if you get a hint with the Patristocrat, that'll usually be extremely helpful when trying to solve them. If you don't get a hint for the Patristocrat, I wouldn't suggest trying to go for it because those tend to be the most difficult kinds of codes to break in Codebusters, at least in my opinion. But yeah, letter frequencies is usually going to be your biggest help when you do a Patristocrat. And then Xenocrypts. Xenocrypts are the Spanish equivalent of an aristocrat. I would strongly suggest that you have someone who is fluent in Spanish or is in a high level of Spanish at the moment. If you don't have someone that if you don't have someone that meets those kinds of qualifications, I would not suggest going to the Xenocrypts. So for invitationals and regionals, they are allowed to have one Xenocrypt, but they can only have one at most. At states and nationals, they will at least give you one. They could have more at states and nationals, but at least one of them will be a Xenocrypt. So I highly suggest that you get someone who's good at Spanish because this is usually a good make or break between a lot of teams if somebody on your team can break it. So you can use most of the same strategies that you use for aristocrats, but you just need to put them into Spanish. So the most common letters are not ETAOIN. Instead, it is EAOSNR. Um, Accents do not exist in these codes. So if you know the word like L, which it can be he if it has an accent or just the if it doesn't have an accent, you won't be able to tell which of the two it is. It's just on the test, it'll just be EL no matter what. So, but they will count. So they'll count the E with an accent and the E without the accent. as the same letter, but letters like enye, that is a completely different letter in the alphabet. So there's only 27 letters in the Spanish alphabet. Um, Again, accents don't count. Two-letter words are usually really helpful: el, la, en, de, es, etc. The word K is also very important if you can figure it out. The most common tenses are probably going to be the present tense, the preterite tense, and the future tense. Other tenses can appear. I have seen subjunctive, imperfect, conditional, but you should know your conjugations. I haven't really seen many of the perfect tenses appear, but again, present, preterite, future, those are probably the ones you need to know the most. So yeah, for letter frequencies and two-letter words are usually going to be your biggest help in these codes. Oh, is this still me?
My bad, I was muted. Okay, so what are the? I know the cipher is the Caesar cipher is one of the most basic shifts, and I forgot to mention this before, but on the rules, there can only be two encrypting problems. So most typically, this will be your encrypting problem since it's very simple and straightforward, and it's just shifting the regular alphabet by a set amount. So if you shifted A by 2 or 3, then A would become D, and that would be, and then B would be E, C would be F, so forth. And so it is basically your job to either figure out what the shift is, the set number of the shift is, or it is given to you. And so encrypting, they would give you the number to encrypt by. So they would say, with the Caesar shift of 3, encrypt this phrase, and then you would type in, or you would type in the phrase shifted. And then decrypted, it's kind of different. Decrypted, they won't typically not give you the shift, and you just have to figure out based on patterns. So just as you said before with the aristocrats, if you see like a single letter, you can try A or I, because those are the only one letter words that will fit, and you can definitely crack the code by then. If not, just keep trying and keep shifting the code until all of it's correct. Then after that, it's smooth sailing.
So the Baconian cipher is it's a cipher that relies on binary to translate the letters. So you might see a couple different ways that a Baconian can be represented. It can be represented through a bunch of symbols, some words, or just A's and B's. But what you need to be able to do is translate whatever kind of message you're giving into a binary code. You on the on the test, they'll usually give you the Baconian table, and it'll be listed as A's and B's. If you wanted to turn that into terms of binary, A will be 0 and B will be 1. So you kind of just need to be able to figure out like which symbol will most likely result in the letter A and which symbol will most likely result in the letter B. Or if it's with words, you need to figure out what kind of pattern there is with the letters being used. Usually it revolves around the numbers that is associated with each of the letters, with A being 0, B being 1, C being 2, etc. And you need to be able to find patterns within those numbers. Like are they using all the odd numbers and making them the letter A, or are they making all the even numbers be the letter B, etc. Once you break it down into A's and B's, you should also chunk it into groups of 5, because each chunk of 5 letters of either A's or B's will translate into one of the 26 letters in the alphabet. So if they were all the letter A's or number zeros, then that translates to the alphabet letter A. And you keep going down with it. I think on some codes you have you get the same letter for I and J and U and V. So you kind of need to, you can't really figure out which of the two it might be immediately. You kind of need context with the other letters and see which one creates the best fitting word. And once you figure that out, you should be good to go.
All right, so the next one is Vigenere, and this is essentially one keyword is given to you, and you have to shift the entire code by that individual letter. So it's kind of a Caesar cipher, but instead of shifting by a certain number, you're shifting by the keyword. So if the keyword was uh, the code, C being, you would shift the first letter by C, the second letter by O, the third letter by D, the fourth letter by E, and essentially it's just a Caesar cipher. Typically on the test, they'll give you one of these tables, as you can see on the right, and you can use that to your advantage by, because it essentially does the shift for you and lays it out on a really nice table. So if you can figure it out and follow the letters, you will get your plain text or ciphertext given, whether it's encryption or decryption. So for the encrypting, they'll give you the key, and you will just shift normally with the keyword, and decrypting is the same, essentially. So our next cipher is the Affine cipher, and it's also one of the most common like encrypting, decrypting type ciphers in which you will encrypt. So this affine cipher follows kind of a formula, and as you can see below, y is equal to ax plus b, where normally, typically they'll give you the a and b. Um, so, and x being your plain text or your ciphertext. You simply just plug in the formula. The catch for this is that you have to use the function mod 26. So essentially, you're doing remainders. So if you had 1 and you did mod 6, your answer would be 1. Um, if you're confused about modulus math, I highly suggest you like look up how to work with it. And just a small tip is that once you plug in one letter, say E, it's going to be the same thing for all the other letters. So you can just, once you figure out the Y for, or the plain text or ciphertext for E, then you can just plug it in for every other E, and it'll save some time. All right, so the next cipher.
All right. It is the Hill cipher, and the Hill cipher works with some matrix math. I don't think we're really going to detail on how matrix math works, but it is important to note that no Codebusters test will ever give you a combination of matrices that cannot be multiplied together. So you should almost always be able to um, successfully multiply. No, you should always be able to successfully multiply with the matrix math. You just need to be able to know how it multiplies with each other. Um, a Hill cipher is not a monoalphabetic substitution, so multiple letters can translate into one single letter from plain text to ciphertext. So, like maybe A's, A, H, and J can translate to the letter V because of the way the numbers multiply on matrix math. Um, when you're encrypting, it's pretty simple. You get the encryption key, and all you do is chunk your plain text into bits of 2 or 3, depending on what kind of size matrix you have, whether it's a 2 by 2 or a 3 by 3. If it's a 2 by 2, chunk them into groups of 2. 3 by 3, chunk them into groups of 3. Um, turn the letters into their respective numbers. A starting starting with A equals 0, B equals 1, etc. Once you get that down, you then turn it into a 2 or 3 by 1 matrix, it should be like one singular column with 2 or 3 rows. Once, and then you essentially do the matrix math. I'm not going to go into how to do the matrix math, but you put the 2 by 2 or the 3 by 3 matrix first, and then your singular column matrix afterwards, and then multiply it accordingly, and you should get either a 2 by 1 or a 3 by 1 matrix as your result. Whatever numbers come out of that, you need to mod it by 26 once again. Again, like Taylor said, you just essentially get the remainder of whatever number you get. You can take the remainder of whatever numbers you're dividing by. Once you get the remainder, that should be your modded number, and then you turn it into the respective letter. Decrypting, it's a little bit more complicated because you're going to get the encryption key and you need to turn it into a decryption key. So you need to first start by turning your encryption key and making the aggregate matrix of it. I do have it on the bottom right there. Essentially, the letters A, B, C, and D all represent numbers, and all you do is swap the positions of A and D and turn B and C into negative numbers. Afterwards, you need to find the inverse of the determinant. The determinant is AD minus BC. Once you get that, you need to get the inverse of it. There's the modular inverses table. So it's like one, the inverse of 1 is 1, the inverse of 3 is 9. The table will be given to you in most Codebusters tests, so you don't need to worry too much about that. Then you multiply the determinant by your aggregate matrix, mod 26, and then you get your decryption matrix. Do the same thing that you did with the encryption, just do it on the ciphertext with this decryption key, and you should be good to go.
All right, so the next cipher is the Pollux cipher. It's a Morse code cipher, so you should be familiar with the chart, although the chart is given to you on the chart is given to you on the test, along with the Baconian and so forth. In this one, there are digits 0 through 9 that are going to represent either a dot, dash, or X. And there must be at least one digit that correlates to each symbol. So you're typically given 6 hint digits on your question, and you use those given hits to start building up your table and then figure out what are the other 3 unknown digits and what are they equal to. And so typically you'll be given a jumble of code being like 10938, and you're essentially turning that into dots and dashes, and then turning the dots and dashes into actual words. It's also important to acknowledge that the X, 1X symbolizes that there is a gap between letters, and 2 X's indicate that there is a gap between words. And often you can use like some logic. So your first digit is never going to be an X. So that is unique, and you can just immediately map that. And so what I like to do is just do the potential like combinations that each number could represent and fill it out into the table. And as soon as the other combination is not possible, erase that. And so all letters are only 4 symbols long at most in Morse code, and they're typically never numbers present in your code, so you don't have to worry about that. But they're typically like 5 symbols long. And so a lot of your solving for the cipher is going to be based around figuring out where your X symbols are. And once you figure out where those X symbols are, you can just use logic from there and just guess and check on what letters make sense with your plain text or ciphertext. Some letters have a unique Morse code pattern that makes it impossible to be any other letter. So if it's not that, then you're basically just using logic to fill out your table.
And the Morbit cipher, it's a very similar cipher to Pollux. Again, it's also relying on Morse code, but the way it works is that there's nine pairings of the three symbols that you get. You can get dot dot, dot dash, dot slash, dash dot, dash dash, dash slash, or an X. Sorry, whenever I say slash, I also mean an X because I think in Thieves they also use an X instead of a slash. So I'll just from now on I'll refer to as X. But the last three are X, X dot, X dash, and XX. So those are the nine pairings that you can have. The digits from 1 to 9 will pair up with each one of those pairs of symbols, and they always and those numbers will always translate to those pairings to the same pairing of symbols. So if one is equal to dot dot, then every single one in the Morbit cipher will also be equal to dot dot. It's you're doing the same thing that you did with Pollux, but instead you fill in all your givens with the pairs and you use logic to figure out what the remaining pairings of symbols are with each number. So maybe in some place there's going to be a string of just dots and dashes and it goes on for a while, but then you figure out that each letter can only have 4 symbols long. It can only be 4 symbols long. So if it's a 4 symbol long code, an X must be at least somewhere. And you then look at which pairings you have used and haven't used, and figure out by logic where the X is most likely going to be, and then figure out which pairing allows you to use the said X in that given position. And once you figure out where all the digits have gone and which pairings they match up to, you can pretty much just solve the code by plugging and checking.
Okay, and then for states and nationals, you'll have cryptanalysis of Vigenere and Pollux Morbit. So basically, you're just trying to figure out the keyword, and you're kind of like going in reverse. So simply do the arithmetic with mod 26 until you can find a certain number for the key, and then see if you can find how long the strip is. Try to figure out the keyword once you fill in enough slots of what you have. For Pollux and Morbit, you figure out the Morse code equivalents for each letter and be able to accurately correspond them to the numbers, either as like a single symbol for Pollux or a pair for Morbit.
For Affine, it's a little bit more complicated. There is a different it is a little more complicated because you do need to do I think a system of equations with this. So using the at least 2 of the given code translations, maybe there's just 2, maybe there could be more. I would turn it into a systems of equations where you have unknown variables of a and b, and you plug x and y in, y being the ciphertext number and x being the plain text number. Once you plug those two in, you can you probably want to do the system of equations solving by elimination. Basically, try to get rid of the variable b and try to solve for a. When you're trying to solve for a, you also need to figure out that you need a number that would be co-prime with 26 for a, because in any affine cipher the variable a has to be co-prime with 26, so you need to keep adding 26 to your y value after you've done a system of equations with elimination. Your new y value needs an additional value of 26. It needs to keep adding 26 to the y value until a is any number of being 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, or 25. If a can become one of those values after you add a certain number of 26s, then a is most likely that value. You then need to confirm what b is by plugging A in and then figuring out what B is from there. If it matches up um, with the two pairings of symbols, two pairings of letters that you get, it's most likely going that you most likely have your A and B values, and then you should be able to solve the rest of the code from there.
Do you want to do this one too, V?
Yeah. RSA, it's a very complicated system using two very large prime numbers and then multiplying them to get a, I forget what kind of number it's called, but the number I the number is essentially has a prime factorization with only those two large prime numbers. Uh, what that does is it makes it almost impossible to figure out what the prime factorization is, and you need the prime factorization to help you solve for the encryption and decryption keys. So by hand, this is essentially almost impossible. But in Codebusters test, they'll give you those two large prime numbers to work with. So you don't have to worry about figuring out the prime factorizations of these numbers. All you need to be able to do is figure out how to decrypt using the values that you get. So there's a bunch of different values you need to understand. Um, the variable capital C is a ciphertext number. It is not one of those numbers where it's like from A equals 0, B equals 1. It is not one of those numbers. It's just some number. So it can be like 1,000, 3,536. It could be any number. Um, M is the plain text number. E and D are both the encryption and decryption key respectively, such that um, if you do if you do E times D and then mod that by another variable of N, it should equal 1. N is just the product of P and Q. So that's the two prime numbers being multiplied with each other, and whatever product you get is N. P and Q are the two large prime numbers. It can be any prime number. Um, and then there's another one that's a variable phi. This one is important in doing iterations of extended Euclidean algorithm. I'm not going to really explain extended Euclidean algorithm. I think Teves does explain this a little more, so you can figure out how to do extended Euclidean algorithm from there. But p minus the quantity p minus 1 times the quantity of q minus 1 equals phi. And you're going to need phi when you're doing these iterations for extended Euclidean algorithm and finding the decryption key. So yeah, they'll give you the encryption key. They'll give you at least P and Q, and they should also give you N. And when you're doing iterations, the the first R value that you're using, which is R0, should be phi, and then E, and then the value for E, the encryption key, is R1. And essentially, you're just going to keep doing, I guess, in a sense, modular arithmetic, and you keep subtracting until you keep subtracting the the R values from each other until you get a number that's equal to 1. Whenever R of some iteration I is equal to 1, then your variable T, which do separately working with other numbers, will be your decryption key. I can't remember where you T. Oh yeah, now I remember. So T is like a completely different set of numbers, but you're working with T0 being 1 and T1 being 0, and it depends on the numbers that you get after you're doing each iteration. When you get the resulting um, remainder from each iteration, that I think you need to use that with your iterations of T. Again, I think Teves does explain this more in depth So I would suggest checking out that website and plugging in and saying that you want to do an RSA question, and then the answer it gives will usually explain how to work with T a little bit better. Did I miss
Alright.
anything?
So yeah, that's it. That's pretty much it. Those are all of the ciphers that we're covering. So if you guys have any questions? We are happy to answer. But yeah,